Row 1 is given a square grid whose side length is an odd integer. The square is divided into 1 by 1 squares. Row 1 shades each 1 by 1 square along the two diagonals and does not shade any of the remaining squares. For example, a 5 by 5 grid is shown in which row 1 has shaded the squares along the diagonals. Row 1 is given a square grid that is 7 by 7. How many 1 by 1 squares does he shade? Well, if you look at the first one that they give us in the example, it's a 5 by 5, right? This is a 5 by 5. And if you look at one diagonal, it's 5. And then if you look at the other diagonal, it's also 5. But then we got to make sure that we don't count this one twice. So subtract 1. And that gives me 9. If I have done that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7 by 7 would be pretty much the same principle. It'd be 7 plus 7 minus 1, which is 13. So that's a quick way of doing that. 101 by 101, which is part B, is the same thing. 101 plus 101 minus 1. And that, I believe, is going to be 201. Part C, row 1 is given another square grid with odd side length, and the number of 1 by 1 squares is 41. How many unshaded 1 by 1 squares? Okay. This is a little bit different. This time they told you that it's 41. So 41 is my n plus n minus 1, following the pattern of A and B, where it's an n by n square grid. So solving this, we get n equal to, I believe, 21. Yeah. So what they want, though, is how many unshaded. Okay, so the total would be 21 squared, which is 441. And the number of shaded is 41. So the number of unshaded would be total minus shaded, which is 441 minus 40, which gives me an even 400. And part D, row 1 is given a fourth square grid with odd side length. After shading the squares on the diagonals, there are 196 unshaded 1 by 1 squares. How many 1 by 1 squares does this grid contain in total? So this is a little bit different. The total is going to be n squared, and the number of shaded is n plus n minus 1, as we've done previously. So this is total, and this n plus n minus 1 was the shaded, right? So that basically means that the unshaded would be total minus shaded. So this minus that would give me basically my unshaded, and they've told me that's 196. So I guess that's just the algebra I have to solve, and shouldn't be too bad. So this is n squared minus 2n plus 1 is 196. And putting everything on one side, we get n squared minus 2n minus 195 is equal to 0. And hopefully this factors n 13, 15 minus plus, and therefore n is 15. And what are they asking for? In total, so that's n squared, and then n squared therefore is 225. The line L1 has equation y is equal to minus 4 over 3x and passes through the origin. Oh, the line L2 has the equation y is equal to minus a half x plus 5 and crosses the x-axis at P. Lines 1 and 2 intersect at Q. What are the coordinates of P and Q? Let's make this diagram, I guess, to the best of our ability. So I'm not even sure how much space I need, but let me just see here. We're going to have... So obviously to plot this, I'm going to need a few points, but what am I... Let me see if I can do it without plotting. I'm pretty sure that one is going to go right through the origin, right? This one, y is equal to minus 4 over 3x. So that's going to go kind of like this. And then the other guy, which is y is equal to minus a half x plus 5. Okay, that one I'm going to need a couple coordinates. So when x is 0, y is 5. Okay, so let's just put that there. And when y is 0, x I believe is 10. Yeah. Well, hold on. Yeah, 10. So I don't know if this is going to be drawn to scale, but Okay, not perfectly drawn to scale, but that's pretty decent, I think. Okay, so let's label this. This one was mile 1, and this guy is mile 2. Okay, and they intersect at Q. So this guy right here is Q. That's right there. Okay, so what is the first thing? What are points P and Q? What's P again? L2 crosses the x-axis at P. Okay, so this is P. All right, so that shouldn't be so bad. To get P, that's just the, I guess, the x-coordinate. So set y equal to 0. So let's see here. That's going to be 0 is equal to minus a half x plus 5. And therefore x over 2 is 5, and therefore x is 10. So P has coordinates 10, 0. And then the next one, Q, that is the intersection. So that's going to be, you got to set these equal to each other. So minus 4 over 3x is equal to minus 1/2 x plus 5. Plus 5. And multiply through by 6 to get rid of all the fractions, and you'll get minus 8x is equal to minus 3x plus 30. And then if you put everything on one side, it looks like you get minus 5x is equal to 30. And therefore x would be equal to minus 6, I believe. And then if you sub it back into either of those to get the y value, you'll get a y value of 8. So Q is minus 6, 8. So that takes care of part A. What is the area of OPQ? OPQ. Okay, so where's O? O is the origin, right? So OPQ. Okay, so that shouldn't be too hard. Triangle OPQ, 1/2 base times height. So the base is 10. The height would be the y coordinate of Q, which is 8. And therefore, that looks to me like that would be 40. Point R is on the positive x-axis, so that the area of OQR is 3 times the area of OPQ. Determine the coordinates of R. So we're going to make this R way out there somewhere. I'm not sure exactly where, but if it's going to have 3 times the area, it's obviously going to be way out there somewhere. So somewhere out here like that. And basically, we would have to extend our x-axis to kind of show that eventually it crosses like that. Okay, no problem. And then what is this now? OQR. So OQ, and then this point right here is my R. And I don't know the coordinates, so I'll just call it whatever, B0. Now, if that area of OQR is 3 times, that means OQR would be 120, since OPQ was 40, right? So 1/2 base times height again, 1/2 base. The base would be B, right? Because you're going from O all the way to R, that's B. And then the height is just, again, the y coordinate of Q, which is 8. Okay, and then when you solve this, we get 4B is equal to 120, and therefore B is equal to 30. So the coordinates of R are 30 and 0. And finally, point S has coordinates 18t with t greater than 0. If the area of OQS is 3 times the area of OPQ, determine the value of t. Okay. Okay, so without making this diagram too messy, I'm going to have to somehow, hopefully it won't be too messy if I just make a line from O to S. Now, where's S? 18. 18t. And what's t? I don't know. So somewhere, let's just say somewhere here. So if that's the case, let's just draw a line to represent that. And so something like this. Let me just see if I can even draw it. Oh, there we go. That's pretty decent. So this represents this guy right here. That point, this point right here, is my S, which is 18t. And they're saying the area of OQS. Okay, so I got to connect these dots here. Okay, so OQ, Q to S, I got to connect that. Okay, so that triangle, I understand. And let me just make another green line. Okay, so that triangle OQS is 3 times the area of OPQ. Okay. All right. Okay, what I'm going to do here is I'm going to draw some lines to make a rectangle, and I think that should make this a little bit easier, I hope. So first line is just down like that, and then the next line I'm going to draw is going to be from here to here. Yeah, make it look like a rectangle, and then one final line coming down through Q like this. And then I will show you what is the reason I did all that. Okay, let's move this up a little bit. Okay, so this OQS, right? Is it OQS? Yeah, OQS. OQS. That would basically be the full rectangle that I just drew in black minus 1, 2, 3 triangles. So minus one triangle, 1/2 base times height, minus another triangle, 1/2 base times height, minus another triangle, 1/2 base times height. And what are those triangles? Well, I don't want to make the diagram too messy, but I guess I just write in this is the first one, the first triangle, that one. So that's going to be 1/2. The base is 18, and the height is, what is the height? The height is t, right? Yeah. Okay. The next triangle is this guy, that one. So that's going to be, again, 1/2 base times height. So 1/2 the base all the way across. So it's going, this was minus 6, right? So it's going from minus 6 to 18, so that's going to be 24. And the height is t minus 8. So t minus 8. And then the last one, the last triangle that I need to subtract is this guy right here. That one. And that's going to be 1/2. Base would be 6. And the height would be 8. So there you go. That's the algebra. Oh, I forgot the full rectangle would be 24 times t. And then we want OQS to be 3 times, so that's going to be 120. So there you go. We got all the math, and let's see if we can solve this algebra to figure out what t is. So we got 120 is 24t minus 9t minus 24, and then minus 12t plus 96. And when you do all this, you get 48 is equal to 3t, and therefore t is equal to 16. And there you have it. Vernon starts with the first number n, with n between 0 and 1. Vernon enters the first number into a machine to produce a second number. He enters the second number back into the machine to produce the third number. Vernon continuously enters the result back into the machine, giving a chain of numbers. When Vernon enters a number x into the machine, if x is less than or equal to 1/2, the machine outputs 2x. If x is greater than 1/2, the machine outputs 2 times 1 minus x. If the machine never produces the number 1, Vernon stops the process. Chain starts with 3/11 and gives 3 over 11, 6 over 11, 10 over 11, 2 over 11. What are the next four numbers in this chain? Okay, so we are going to start with this 2 over 11, right? This guy right here. Okay, is 2 over 11 less than a half, or is it greater than a half? Well, it's less than a half, so then we're going to output 2x. So that means we're going to output 4 over 11. Is 4 over 11 less than a half or greater than a half? It's less than a half. So we're going to output again 2x, and 2x of that would be 8 over 11. Now we get into a situation where it's greater than a half, so then we have to output this guy. So that's going to be 1 minus x would be 3 over 11 times 2 would be 6 over 11. And 6 over 11 is again greater than a half, so again we're going to output this guy. So 1 minus 6 over 11 is 5 over 11 times 2 would be 10 over 11. So there you go. That's all they're asking for. These are the next four numbers, 1, 2, 3, 4. Vernon enters a number x between 0 and 1 into the machine and produces the number x. What value is x? Okay, well, if x was less than a half, he would produce 2x. So then x would have to equal 2x. That would mean x would be 0. And is that possible? Can we have 0? Is there some condition? No, because it has to be greater than 0. So that's not valid. But if x was greater than a half, he would output 2 times 1 minus x. And they're saying that the output is equal to the input. So that means x is equal to 2 minus 2x. And therefore, 3x is 2. And therefore, x is 2 over 3. 2 over 3 is the answer. See, the fourth number of the chain is 1. Determine all possible values of the first number in this chain. So 1, 2, 3, and 4. And they're saying that the fourth number in the chain is 1. And they're asking you, what is the first number? Okay, so I think there's going to be a few possibilities. So let's see. If this input here was less than a half, we'd do 2x. So this would have to be a half, because if you did 2x, then you'd get 1. And then whatever this input is, if it was less than a half, we would do 2 times 1 minus x, right? And that 2 times 1 minus x would equal 1. So that would mean 1 minus x is equal to a half, and therefore x is equal to a half. But then if x is a half, then we would use the 2x. Yeah, so this doesn't give us anything. So the half is the only option there. Okay, for the third number. Okay, so now let's go to what are my possible choices for the second number. If I'm doing a 2x, then that means this is a quarter. But if I'm doing a 2 times 1 minus x to get a half, I can't do that in my head. Probably should be able to, but let's just do the math. No big deal. 2 minus 2x is a half. So 2x is equal to 3 over 2. So x is equal to 3 over 4. So this is a 3 over 4. All right, moving right along. I think I'm going to need a little bit more space here, so I'm going to put the 1 over 4, 3 over 4. Now I'm back. I'm at my first number now. Okay, so what kind of options? 2x, 2 times 1 minus x, 2x, 2 times 1 minus x. So if we're going to 2x, then that's going to be 1/8. If we're going to this 2 times 1 minus x, all right, let's do the math here. 2 times 1 minus x is equal to a quarter. That means 1 minus x is equal to 1/8. And that means x is equal to 7 over 8. So this is 7 over 8. 2x, that should be pretty easy. 3 over 8. And then finally this guy, 2 times 1 minus x is equal to 3 over 4. So 1 minus x is equal to 3 over 8. And therefore, that's going to be 5/8, I believe. So there you have it. Those are the 4 possible values of the first number in the chain, either 1 over 8, 7 over 8, 3 over 8, or 5 over 8. For some positive integers m greater than 3, if the first number in the chain is 2 over m, then the 8th number in the chain is also 2 over m. Determine the 3 positive integers m for which this is true. What they are saying is you have initially a number, and they're calling it 2 over m. And then eventually, 1, 2, 3, 4, 5, 6, 7, and 8. This 8th number is also going to be equal to 2 over m, like that. So those are the conditions to go from 2 over m all the way back to 2 over m again. And they're saying, for what value of m does this happen? Okay, well, let's just talk about this first instead of jumping right into it. And m has got to be greater than 3, so that's very important. So let's try m equals 4. Let's see what happens. This will be 2 over 4, and that's a half. So basically, according to the rules, if it's a half, you have to double it, so it becomes 1. And then if it's 1, I think you can't have 1 because n has to be... So then it doesn't work. You stop, actually. I think I remember that. Yeah, if the machine ever produces the 1, Vernon stops the process. Okay, so I guess we just stop. So for 4, when m equals 4, we never get it. We never even get beyond the second one. Let's see what happens with m equals 5. I'm certainly not going to keep going. I just want to see. This will be 2 over 5, the first one. And then this, you're going to double it because it's less than a half. And this is greater than a half. So you're going to do that 2 times 1 minus x, right? So it's going to be 1 over 5 times 2, so 2 over 5. So this is the third number. And then the fourth number, that's going to be 4 over 5. This is going to be 2 over 5. Oh, this looks like it kind of just alternates between 2 over 5 and 4 over 5. Let's see if what we get at the end is the same. Oh, no, we just missed it. Okay, so we didn't get the same. This is not the same as that. But you guys get the idea. They want you to know, they want you to figure out, actually, for what value of m can you go from 2 over m to 2 over m after 7 steps, right? Because it's 1, 2, 3, 4, 5, 6, 7. Okay. All right, well, we have 2 possible ways of changing the number. Either you make it a 2x or you make it this 2 times 1 minus x, right? And this happens if the input is less than or equal to a half. And this happens if the input is greater than a half, according to our standard definition up here. You guys remember that. Okay, so these steps, these 7 steps, well, m, no matter what m is, it seems like the first step is always going to be an a, like this guy right here. Yeah. It's always going to be an A. Because as you see, when m was 4 as a half, but any value of m greater than 4, that first value, 2 over m, was going to be less than a half. So we're going to start off with an A. But then the other ones, I'm not sure. 1, 2, 3, 4, 5, 6, 7, right? Well, I think the only thing we can do is experiment. So how about if they're all A's, meaning it always remains less than a half? Let's see what happens. If that's the case, you're going to go from 2 over m. I'm not going to write 2 over m. I'm just going to let 2 over m equal x. It just makes it a little bit easier for me to write out. So you're going to go from x to 2x to 4x to 8x to 16x to 32x to 64x and then finally to 128x. right? 1, 2, 3, 4, 5, 6, 7. Okay, and then we want that 128x to equal the x, right? And that's only going to happen if x is equal to 0. But x can't be 0. X has to be between 1 and 0, if you remember all the way at the very beginning. So that didn't work, but not a problem. We can just keep going. Now back to my experimentation of my 7 possible steps. I did the all A's. Now let's say it remained less than a half until the very end, and at the very end the input exceeded a half. So remember, this is if the input is less than or equal to a half, and this is if the input is greater than a half. So let me just see if I did, yeah, less than a half, greater than a half. So I'm assuming in this scenario that it's always going to be less than a half, and at the very end we're going to get a value that's greater than a half, and therefore we'll have to do B. Okay, so let's see what this does. This would be somewhat similar in terms of the first few steps. So we're going to go 4x, 8x, 16x, 32x, 64x, and then the last one is going to be B. So you're going to apply to this 64x this guy. So it's going to be 2 times 1 minus 64x. Got it? And then we want this to equal this. So we want the x to be equal to 2 times 1 minus 64x, like that. Okay, so x would be 2 minus 128x, and therefore 129x would be equal to 2, and therefore x would be 2 over 129. And this represents 2 over m, right? So therefore m is 129. So that's pretty good. I got one value of m. Okay, so we're going to keep going with this process. Now, what if I modified my 7 steps where the first 5 I'm doing the A, but then when I get to this point, the input is greater than a half, so therefore I have to apply B, and then B once again. So this one, very similar, but it will change eventually. 2x, 4x, these guys don't change. 8x, 16x, 32x. Right, because these are all A's. Let me just write in those A's so you keep track. A, and A. But the next one, that's going to be a B. So that means it will be 2 times 1 minus 32x. And if you do that algebra, it's 2 minus 64x. And then the last one is also going to be a B. So it's going to be 2 times 1 minus this 2 minus 64x. So you just got to make sure you do it carefully. And that, if you do the algebra, well, that's okay. I'll just leave it like that. And then we want this to equal x. So we want x to equal 2 times this 1 minus 2 minus 64x, like that. And let's see here. So this will be 2 minus minus 4, and then minus 128x, right? Let's see here. Sorry, it should be plus, because it's going to be minus. Yeah, it's going to be plus. So that means this will be 127x, and that's going to be a 2. So x will be 2 over 127. And since that represents 2 over m, my m here is 127. Okay, so we got another value. All right. And then we keep going by this methodology. Same kind of story, but now we're going to assume that we have 3 b's at the very end. So this is going to be b, 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 meaning we stayed inputs less than a half, and then eventually we get to inputs greater than a half after 4 turns. So we're going to go x, this times 2x, 4x, 8x, one more 16x, and then at that point, let me just keep track here if I did this correctly. This is a, this is a, this is a, this is a, and this is a, and then the next one, yeah, is going to be a b. So after 16x, right? Yeah, let me just make sure I did that correctly. Hold on. X, I got, how many? I got 4. Oh, I think I did too many. No, that's going to be b. This is going to be b. Yeah, after 16x, it's going to be a b. So it's going to be 2 times 1 minus, hold on, let me see here. 1 minus 16x, yeah. And that, if you do the algebra, is 2 minus 32x. And then you're going to do another b. So it's going to be 2 times 1 minus 2 minus 32x, like that. And that, if you do all that algebra, is 64x minus 2. And then one final b. So it's going to be 2 times 1 minus 64x minus 2 in brackets. And that should complete it. And this, let's see here. If you do this algebra, it's 6 minus 128x. And we want this to equal that. So we want x to equal 6 minus 128x. So therefore 129x is equal to 6. Therefore x is equal to 6 over 129. And this in lowest terms would be 2 over 43. And since that represents 2 over m, m is 43. And these 3 values are the only 3 values that will work. So we got 129, 127, and 43.